Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Azmi bin Mat Saleh. My metric number is CE170048. I am from section 2 group 3.
Good morning, everyone. My name is Xiao Yong Hong, and my metric number is AE170109.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Muhammad Pafi Samka bin Nuruddin. My metric number is CE170029.
Hello and a very good morning to everyone. My name is Rihanna Jerome. My metric number CE170140.
Hi, my name is Muhammad Iqmal bin Muhammad Taib and my metric number is DE170115. And our project is Smart Fertigation.
So today, my group members and I would like to present our project for Integrated Project Design 1, which is Smart Fertigation. Before I start with the presentation, I would like to introduce our group members. First, Muhammad Iqmal bin Muhammad Taib. Second, Yap Yong Hong. Third, Nur Muhammad Wafis Hamka bin Nuruddin. Next, Ray Anak Jerome. And lastly, me, Azmi bin Mat Saleh. Our supervisor is Dr. Muhammad Najib bin Ribuan. Introduction. In Malaysia, agriculture is one of the most important industries besides oil and gas. Plants are very dependent on fertigation and irrigation system to bring good yields. Different plants use different types and mixture of fertilizers. Smart fertigation is one of the key solutions of smart farming. This automated fertigation system enables every grower to master fertigation at any level. Smart fertigation is a fertilizer application method in which leaves of fertilizers are delivered to the crops through the irrigation system. It delivers just right combination of water and nutrients directly to the roots of each plant according to the crop development cycle. It is suitable for automated commercial greenhouse, hydroponic operations, and agriculture fields. Smart fertigation system management has been proven to achieve higher yields and quality for high-value crops such as lettuce, tomatoes, and others compared to the other irrigation methods. Planting app development not only enables users to learn professional planting knowledge but also enables them to remotely monitor whether the temperature, soil, and humidity of plants are suitable. The growing environment is mainly divided into the following 6 aspects, which are nutrients, temperature, water, air, light, and pH value.
This is my slide for the problem statement. As you can see, it is a challenge for a person to grow plants. It is difficult and a person might make a lot of mistakes to grow a plant without a proper guide. First of all, to understand the planting knowledge inside the apps and the latest comprehensive crop from a professional knowledge. As you can see, provide user with a comprehensive maintenance guidelines such as planting soil, insect resistant, and nursing skill. Second, can reduce human power as prerequisite for remote control as the user use intelligent sensor. The two is linked to the app so that user can provide the plants with the right amount of nutrients. Third, understand the growth stage through the mobile apps. User can accurately know the current growth of stage plant such as germination, root, and so on. Lastly, can improve the maintenance of this crop.
In this project, we have 3 main objectives that we want to achieve, which is number 1, we want to develop a platform for the people in order to assist them and provide actions that expert farmers have, such as their soil observations and their appropriate rates of nutrient intake for the crops. This will help even an experienced person to plant their own crops because of this platform. This platform will give all the informations that they need, such as the soil conditions, the weather conditions, and the platform even recommending the nutrient intake for the crops. And number two, our objective is we want to build a device that can detect the plant nutrient, the temperature, the water, the air, the light, and the pH level. This is because all of these factors are important to grow a healthy crops. With this device, we want even an experienced person can monitor the crop's condition truly, so the crop will stay healthy without any problem. Number three, we want to build a device that can be remotely accessed anywhere and allow the entire fertigation process to be monitored and controlled from anywhere around the world. This is because we don't want farmers stuck in the workplace having to monitor the plant only. With this remotely accessed device, farmers can observe their crops conditions from home or even the other side of the earth, as long as there is internet access. It's suitable in time like this because the virus COVID-19, so the farmer don't have to go outside, don't have to go to the farms just to observe the plant. So for our project scope, we using Arduino Uno for our brain of the system. Arduino is an open source platform for electronic projects. It consists of both physical programmable circuit and piece of software or IDE, which is integrated development environment that runs on computer. The reason we use Arduino as our brain is the program codes are much easier to be read, and most of the actuator and sensor are compatible with it. Arduino will act as a brain for the system, which will receive and sending or transmit electrical signal to actuator such as water pump valve, and to the sensor such as soil sensor. Arduino power is run around 12 volt, which make it less power consumptions. So for our soil detector, we using a soil moisture sensor. It is consists two probes that measure the volume of the water in the soil. The two probes allow the electrical current to pass through the soil, and according to its resistance, it measures the moisture level of the soil. When there is more water, the soil will conduct more electricity, which means that the resistance will be less, so the moisture level will be higher. Dry soil reduce conductivity, so when there is less water, the soil conduct less electricity, which means it has more resistance, so the soil level must be lower. With this sensor, it can determine whether the crop's soil is dry or otherwise, and send signal to the Arduino so that the brain can decide whether or not to open the pump. For our monitoring platform, we using Blink. Blink is a platform with iOS and Android apps to control the Arduino and Raspberry Pi. It is a digital dashboard where the user can build a graphic interface for project by simply dragging and dropping widgets. By using Blink, we can send all the data from our system to the user phone. This will help the farmer to monitor all the process anywhere they are. For the mixture tank, we using a mixture pump to mix all the chemical and solenoid water valve to control all the chemical flow from mixture tank to the crops. A pipe as a medium from the mixture tank to the crops, and a water level sensor to determine the water level in the mixture tank. With this project, we hoping to develop a system where we can replace expert farmer to monitor the crops, and all the fertigation process will be automated. We also wanted the process to be monitored and can be monitored and accessed anywhere by the farmer.
I will explain about the methodology of this project. Firstly, for the block diagram, we use Arduino Mega for our controller. We have a few input and output sensor for this project. The most important sensor that we use is EC meter. EC meter used for to measure the concentration of the fertilizer in the main tank. Next is we use a ultrasonic sensor. Ultrasonic sensor is a sensor that used for measure the level of water in the main tank. The next is we also use water pump. Water pump used to transfer the fertilizer and water from the tank A, tank B, tank C to the main tank. We use water flow sensor to limit and measure the quantity of fertilizer that we use for plant. This water flow sensor will get the correct amount of water that only we need. The last is we use ESP8266 is the modular for the Wi-Fi to Arduino board. The last is we use display. The display we use will display out the value of EC meter, which is concentration of the fertilizer, and the water level sensor. Next is I will explain about flowchart. For the flowchart of the project, I will explain from the top starting. Okay. Firstly, it will start by using the power supply. And second is the Arduino will read all the sensor value. And this part will split into the three levels. Firstly is water level using ultrasonic. Second is push button uses push button to set the ratio of the water and fertilizer. The third is EC meter for concentration of fertilizer in the main tank. For the push button to set the ratio of quantity water and fertilizer, it will display the value of the fertilizer. The next is it will goes to microcontroller or Arduino. The Arduino we use is Arduino Mega. And next is after display the value of the fertigation, the Arduino or microcontroller will memory all the data that we use. Then Wi-Fi ESP8266 will be used for our IoT system, and then it's connect to server, which is our phones. Water flow sensor will be used to get the measure of the quantity fertilizer and water that we need. After that, motor will be pumped from the tank fertilizer and tank water goes to main tank. And then if get the amount of fertilizer and water that we need, the motor pump will be stopped. For the water level sensor using ultrasonic, it will display out the water level in the main tank. If the tank is full, and then the motor will stop. If the tank is not full, it will go to the microcontroller or Arduino. For the EC meter of the fertigation, it will display the value of the EC meter, which is the concentration in the main tank. After that, it will go to the microcontroller or Arduino.
I will presenting about challenge to complete the project during MCO. There's three challenges about the complete the project during MCO. The first one is communication problem were caused by the distance between the member. Next is couldn't make prototype, and the third one is poor presentation and lack of opportunity to improve the product. For the communication problem were caused by the distance between the members. There's a lack of cooperation among the group members, and it can be said that the group member basically have a little or no contact. The communication between the team member and the supervisor was greatly reduced. This can say the team member very less contact with the supervisor, and as the result of the problem of MCO, the contact with the supervisor could only be made through social network software just like the WhatsApp, but most of the team members did not cooperate with the supervisor well. It can be said that communication is basically the biggest problem caused by MCO, and also can be said to be a kind of escape behavior for students. Next is couldn't make prototype. Basically, our IDP showcase wanted to show a prototype and we have created. Because of MCO, the showcase is cancelled and changed to the online recording video to show our product simulation and demonstration. Then, because of this reason, our topic was not very suitable for online simulation display. This is because a lack of some hardware, and also make it impossible to test our program code. As a result, we choose the 3D drawing software AutoCAD to demonstrate the concept of our product. This is also due to the fact that most of electronic circuit simulation software missing some electronic component parts of our product. Next is the poor presentation and lack of opportunity to improve the product. We all know you don't know the fault and you can't improve until you make them. We know that when we need to successfully build an electronic product, we will experience some failure, whether it is improper or some mismatch electronic hardware or software program code to make it run. We will experience all kinds of errors that cause the operation to fail because we are in the distance of the period of MCO. This makes that we have no chance to modify an innovation because the next phase of our project is about modification and innovation. In the next phase, the product must become better and have some improvement, but because it was a conceptual demonstration, we are lack of opportunity to improve our product because we didn't physically build out the product.
For the demonstrate, we have a few problem that will make our circuit cannot working properly. However, I will explain a few more about our project, how it works. We have 3 tanks that will contain the fertilizer and the water for the main tank. The quantity of water and fertilizer that will be used will be set by the worker. Using the volume of the fertilizer and water will be set by the worker using this controller. The volume of fertilizer and water will be adjust for the using this button. This button will use for increase and decrease, and the other button will display the concentration of the fertilizer, which is AC meter, and the volume of water in the tank. This water pump will use to transfer from the tank fertilizer and water to the flow water sensor. Flow water sensor used for to measure the quantity of the fertilizer and the water that we get the correct amount. as we set by the controller. Next is water and fertilizer will be transferred to the main tank. This tank contain a few of sensor, which is EC sensor. EC sensor will use for to measure the concentration of the fertilizer and water in the main tank before use for the plant. Then the water level will use ultrasonic sensor. This sensor will measure the quantity of water in the tank that prevent from the overflow water. So this is how our project works.